So in this portion of the chapter, we'll be talking about motivation and emotions. Now, motivations are things that are incentives for us to reach our goals. So having a goal, sometimes we are going to need motivations. Motivations are incentives that are either internal, so coming from, our self motivations, or things that motivate us from the outside. So maybe societal motivations. We also have emotions. Those emotions are a result of the relationship of our own personalities with other individuals and how we interact with other people and the environment. So you need to know that these motivations and emotions are very different from one person to another. It even changes within that one person. So what might motivate me as when I was a 15-year-old would be very different than what would motivate me as a 50-year-old. So these motivations and emotions keep on evolving and they're changing over the years. Now, motivation can either be led through hormonal and autonomic or behavioral responses. So these hormonal or autonomic, these are things that we're not really aware of that are happening. So for instance, if we're dehydrated, our antidiuretic hormone levels go up and that makes us thirsty. So now our motivation to drink was a hormonal motivation, and that is the increase of the antidiuretic hormone. It is something that we're not consciously aware that is happening. It could be behavioral responses. So let's say, for example, you study, you get a good grade. Okay, so that is a behavioral response. That is a motivation to get things done. Now, there are two different kinds of motivation behavior. There's primary and secondary. Primary motivated behavior, that is related to homeostasis. So think again of that person that is dehydrated. Their antidiuretic hormone levels are up. They are now primarily motivated to drink. Okay, and that again was related to their homeostasis. But what they choose to drink is related to their secondary motivated behavior. And so are they going to choose a glass of water, or are they going to choose a Pepsi or Coke to drink? So again, the play here or the role here as a healthcare provider, or as maybe in the future a dietitian or a nutritionist, or giving your patients, trying to motivate them. Really, we cannot really do much about this primary motivated behavior, but it's all about the secondary motivated behavior. So making sure that they make the right choices when needed. So when they're thirsty, you want to give them these healthier choices to motivate them to choose them. If they're hungry, again, you want to motivate them to choose the healthy choices. So this is an example of how advertising and societal norms change over time. These right here, all three of these are ads for smoking that were up in the 50s. They would show you doctors that are smoking. They would even have babies in the ads. It's just different ways of commercializing, different ways of motivating things, changing the societal norms to it is healthy, it's not dangerous for kids, you look like upper class society. So these are the ways that back in the 50s and 40s, how smoking was being advertised. Now, though, things have changed. And again, this goes back to the secondary motivational behaviors. You can change them by changing these very, these messages that are being sent out to society. So, for example, every single cigarette box now or package would have to have this warning, that it is not safe for pregnant women, it is dangerous to kids, and so on. And then you could also see it to the other extent where, if you're trying to smoke in order to fit in, well, you are going to get rotten teeth, and that's not very attractive, and that's not a great way to fit into society. So again, trying to play with these motivational, not play with it, but to manipulate it is a constant struggle between advertising and healthcare. And that doesn't apply to smoking only. It applies to food. It applies to sports and so on. So motivation, much of our behavior will fit into the secondary motivational behavior. So as I said, primary is more hormonal and autonomic. The secondary is where we consciously start making choices. And that is influenced by habit, influenced by learning. It could be learning, what is norm for my family versus what is norm for yours, what is norm for this society as opposed to another one. Even the societies keep on changing, as you've seen how these ads have changed over the years. It is also motivated by intellect and how much I know versus how much I do not know, and emotions. Okay, so all of these factors, you can kind of lump them in as incentives. Okay, so what is my incentive for getting a shot, for getting vaccinated? What do I know about vaccines versus what I do not know about vaccines? So the more I know about different things and the more I make an educated decision is definitely a good incentive to make the right decision for you. So the concepts of reward and punishment cannot be separated from motivation. So whenever you are making a decision to do something or not do it, you have to really go through what are my rewards and what are my punishment for not doing, pros and cons. And we have seen through lots of research that the reward system better than the punishment system. So positive reinforcement helps. And that is really important in kids. In kids, rewarding kids for good behavior, that positive reinforcement works so much better than punishment and negative reinforcement. Negative reinforcement has shown over the years that it just teaches kids how to avoid being caught. Okay, it does not change their behavior most of the time. It just teaches them, okay, now I know that I was caught because I was seen doing this. Now I'm going to make sure that I'm still going to do it, but I won't get caught the next time. Okay, so positive reinforcement is really what you want to go for, especially in changing risky behavior in kids and adolescents, where, if you do this good thing, you are going to get that. So just a personal story here, my son, who has severe allergies and severe asthma, needed to start taking allergy shots. Okay, he was very against it, and it was going to be a huge struggle for me to be able to take him for these weekly shots, sometimes even twice a week. And that was going to be a huge burden on us as a family, having to go through that twice a week. So I used positive reinforcement where I was sat him down and if you get these shots done, and he really wants a cat, but we can't get one because he's allergic to them. So my positive reinforcement was, if you get these done and you're not allergic to cats anymore, we will get you a cat. And, okay, I had to bribe him. Okay, so positive reinforcement kind of ties into bribing a little bit. But I also told him that each week when you get the shot, without any struggle, you'll get something. And that something could be very, maybe a Slurpee from 7-Eleven or just an ice cream cone or something. Doesn't have to be something, really expensive or anything, but there's again that reward system that worked, and it is working perfect. So your neural system is always going to look at your rewards, look at the punishments, and it'll balance those. Okay, and we'll see how that is part of what is known as the reticular activating system. Now, the chemical mediator for the reward system and for motivation is dopamine. So the more dopamine we have, the more motivated we are to do stuff. Less dopamine means less motivation. So dopamine is good, but having too much of it can lead to psychosis and can lead to psychotic disorders. So you want to have the right amount of dopamine in order to be motivated to do things. Now, amphetamine, which is a drug that is usually abused, okay, that increases the levels of dopamine. And again, amphetamines are used to increase positive reinforcement, to increase the motivation of people to either go through a race or to study and so on. So, and it acts due to the increase in the levels of dopamine. Okay, not a good thing. A drug that blocks dopamine receptors is known as chlorpromazine. So that's one of a dopamine receptor blocker. Can be used as an antipsychotic medication. Okay, remember that high levels of dopamine can lead to psychosis, and if you block those receptors in psychotic patients, using chlorpromazine, that is a way to treat them. So what are the pathways for dopamine? We've got two different pathways. There's a mesolimbic and a mesocortical pathway. So we have these neurons that are in the brainstem and in the limbic system and in the cerebral cortex. These pathways all use dopamine in order to evaluate your pros and cons and then kind of decide, what am I going to do about it? So there are incentives, reinforcers, and this is also the pathway that is more active in gamblers. Okay, so gamblers that have, or in patients that have a gambling problem, it is due to the activation of this pathway, the mesolimbic and the mesocortical pathway. So although they know that this might harm my family, I might not be able to pay the rent this month, but I'm still going to use that money to go and gamble. So that is due to the hyperactivity of dopamine in the mesolimbic and the mesocortical pathways. And here's a little video kind of explaining how this pathway works, so I'll let you guys watch it on your own time. Now for emotions. So emotional behavior is studied more easily than actual emotions. So asking a person about their emotions are internal. So those are hard to measure, but we can measure behavior. Okay, so we can look at a person's behavior and try to figure out their emotions through their actions, as opposed to asking them direct questions, are you happy or not? There are parts of the brain, different parts of the brain that are responsible for different emotions. So for example, part of the brain called the amygdala is responsible for the emotion of fear. So there are individuals that have a bigger size amygdala, and they do experience more fear than others. Patients that have maybe destroyed amygdala might not be afraid of things that they should have, okay? So your amygdala is responsible for that emotion of fear. The cortex, though, is responsible, especially in the frontal cortex, is responsible for how you react to that fear. So your amygdala is going to experience the fear, but whether you run or scream or cry or just don't do anything at all is mediated through your cerebral cortex. So your cerebral cortex is responsible for your emotional behavior. So again, your forebrain has the ability to understand what's going on. It has the ability to modulate your behavior and inhibit emotional behavior. So let us say you're in a situation where you want to scream. Okay, you're scared and you want to cry out for help. But if you cry out for help, then the person trying to chase you is going to know where you are. So you are able to inhibit that emotional behavior and modulate your behavior thanks to the forebrain. Forebrain is part of the frontal cortex. We don't really have a center for emotions. So there's a whole emotional system, and that emotional system is made out of different parts put together. And these different parts are known as the limbic system. So the limbic system will make us feel these different emotions, whether they're fear, anxiety, and so on. And we know this because under surgery, you might have seen these maybe in movies, where the patient is undergoing surgery, but they are awake. And under stimulation of certain parts of the limbic system, the patient will tell you that they are experiencing fear or anxiety, while when we stimulate other parts of the limbic system, they have these pleasurable sensations. So limbic system, generally speaking, is responsible for a whole different wide range of emotions. So here is an example. This is actually my picture over in, normally I would not pet, reptiles, but so my primary response to this would be to run. So if I see this in the wild, my obvious behavior, my obvious response would be to run away from it. But my modified behavior, so my frontal lobe, my forebrain, understands that I am in a controlled environment. Okay, the risks are very low of this trying to attack me. So my emotional behavior was inhibited and I was able to pet them. Okay, so again, you can see how your limbic system, so my amygdala was definitely afraid of it, but I was able to modulate my response to it according to the situation. And that again happens due to the, taking in lots of data and interpreting it using different association areas. Okay. Now, right here, this is the limbic system. So all these pink parts make the limbic system. And you see here that it's not just one part of the brain. There are lots of different parts that are in there. So we have the hippocampus, we've got the amygdala, and we said that's for fear. We have parts of the hypothalamus, parts of the thalamus. We've got the prefrontal cortex, the cingulate gyrus, and just, different parts that kind of come together in order to make the limbic system that are involved in emotion, motivation, and affective disorders. So disorders of these areas can lead to different mood disorders. Here you can see in this computer image of a brain scan, of a thermal scan, where this person is having sad thoughts. So there is activity in different parts of the brain. So you see here activity in the occipital lobe, in the frontal lobe, some in the parietal, but the prefrontal that has the red and the yellow, that is the area of the most activity. That is the area where all of that information coming in from the occipital and parietal, all of that is kind of being integrated here, and that this person now is experiencing a sad thought because of maybe something sad that they're watching on TV, something maybe that they touched and they're experiencing these general senses through their parietal lobes. But again, you see that having that said, having one thought is not just related to the activity of the limbic system. There are other centers that are definitely involved in our different emotions. Okay, at this point, I'm going to end this portion and I will see you in the next.